what we could have done to increase the, means to efficiently detect the RUCO marker is by increasing the size, because there is also a size limit, and the position of camera, means how up or down the camera is. What we could have done is, means when the RUCO marker is not detected, we just have given the previous velocities to the bot, means in a proportional amount, or just reduce the speed, so it will.
Okay, thank you, team 1562. Thank you, jury. Okay.
Just
you might have seen the picture as always on the screen when it was being, when the jury interaction was going on. So, yeah. Okay, we'll move on to the next and final team for HolaBot, which is team Vishwakarma Institute of Technology, Pune, team 1591. Please introduce yourselves.
Hello, I am Dhruv Thakkar from second year computer engineering, and he is Prasanna Gebise from second year ENTC. We are from Vishwakarma Institute of Technology, and we are HB 1591.
Okay,
Okay, we are the two teammates from Task Zero itself, the two left. Okay.
Okay, team is ready.
Okay, I will do the counter for the timer starting.
Okay.
Okay.
We'll synchronize. You just have to switch it on, right?
Yes.
Yeah. You can be on the scorers ready. Jury is ready. Okay. Ready. 3,
Start kar do.
2, 1, and go.
Okay, so now it is going to draw the image first. So we have tuned the image mode differently with the different KPKs, and the function mode is tuned differently. So first it is drawing the bigger counter. As you can see, the first counter was the bigger one. So as you can see, the theta is extremely stable. It is maintaining the 0-degree angle with respect to the y-axis, and it is not moving. So our KPK is as robust as it can draw any image. So now, while switching from one counter to different counter, we have implemented a logic that giving waypoints between the two counters so that it cannot dislocate or move random motions, and it is going in the perfectly straight line till the second counter. And as you can see, the motion of the brush is also smooth. The pen up down mechanism is independently, both pen up down mechanism can work independently, so we don't have to do any manual intervention for the function mode. So the point in a bot is it is smooth while making the image mode, as we have given, we have applied a logic for the sending messages. So our laptop is sending a string that contains 3 wheel velocities. It is given to the ESP32, and ESP32 serially communicates with the Arduino Uno with UART communication. So in this string, we are sending 3 wheel speeds and 2 pen locations, that is 1 and 0. So Arduino is extracting 5 data from that. So to tune it, to make it a smooth motion, we have implemented a logic that while the new message is not received, it will continue to the previous speed, and that's why it is making a smooth motion.
So speaking about the pen up, pen down mechanism, we decided at the beginning that we'll use the paint process. Like markers can be good, but they're not good for all surfaces. So like paint process can be good at any surface. So first of all, we used just fixed brushes, but later on when the function mode and image mode combo is introduced, we thought that let's use a pen up and down mechanism. So we settled by using two pen up and down mechanisms. So there is no need of a third brush. Like image mode can be done by individual one pen, and while function mode, both pen can go down.
Now the function mode is started. As you can see that the angular motion is very perfect. The KA is tuned perfectly. There is no overshoot as we have implemented a PD controller together. So the D controllers supports tackles the oscillations and overshoots. And the KPKA is tuned differently for the function mode because it has a theta motion, and the image mode was too stable, has the stable theta. So now the function mode is completed. Just okay, the run is completed.
Thank you, team. Here you will notice, in comparison to the second last team, jury and the audience, that the function mode is in contrast to the second last team, the pen positions are very far apart. In the second last team, the pen position was very close together. So they both plotted the same function, but it was just a difference of where they placed the pens, right? So yeah, okay, you can move on to the jury interaction.
Congratulations on a great run. Please have a seat.
Thank you.
Quickly tell us about the hardware and the software design, the salient features.
So the salient features of our hardware are basically we have used acrylic sheets. We have laser cut acrylic sheets for the chassis. So we could have 3D print, but instead this was more economical, and it did the job. So we have basically used three like acrylic sheets. In the most down section, we have a custom made power distribution board. So we have soldered it on a 0 board, and we had 3 stepper drivers. So we had to distribute powers equally. So that along with the Arduino Uno is placed at the bottom, and in the middle we have the EFI Mega board. So actually our EFI Mega board's ATmega section got corrupted. So that's why we had to use the Arduino Uno. So we used a UART communication between the ESP section of EFI Mega and the Arduino Uno. So our EFI Mega and battery are placed here. And speaking about the pen up and down mechanism, we have 3D printed it, and all these things were designed in Fusion 360, and I have designed it in Fusion 360. So we thought that more reliable mechanism would be better. So we have used a bearing here. Like you can see, there's a housing, and bearing is used inside, so that the pen up and down is smooth. And when the pen is down, it is rested on this servo mode. So there's no like error or no jerkiness. Yes. So this was about the hardware part.
About the software, we are just using a simple Python file. So this Python file is communicating using the socket connection with the ESP32. The ESP32 has a only job to connect with the laptop, and it is sending the same string received to the Arduino Uno. And the job of Arduino Uno is to extract the different wheel velocities individually. So there also the time complexity matters, how speedily the wheel velocities are extracted and it is given to the wheels. It matters, and we have did it very well. And also about software, about contours, first about the detection of Haruko marker. The light condition matters. In our hostel, the lighting condition was different, and here it is different. So we have we have noted a range of thresholds. So if we are changing the environment, we are able to make the detection properly by just changing those ranges, and the Haruko detection is no worries now. And about the yes, the Python file is modular completely. We can change the size of the image. We can give the KPK differently for every contours. Between the contours we are giving a line, so we can give that KPK for that motion. We can give KPK for different different function modes and image modes. Okay, majorly the software part was done by me, and the electronics and the modeling part was done by Prasanna. The other two people have not contributed since task 0, so we decided to go forward with 2 people only. My name is Dhruv Thakkar, and he is Prasanna Gebi, sir. The workload was every theme of eYRC is dominating in both electronics and software part. So electronics part was because I know the electronics also, so we both divided the electronics equally. But the software part was completely on me. So if a person which have the same level of this software part would have divided with me, it would be better. But the workload was very high. Both were equally important. In the previous task, software was only dominating, but when the hardware was shipped, the electronics part also was a major issue, and we both worked together on it.
Who figured out this mechanism?
We just saw some CNC plotter, something like that. But then we it just like we started by looking at different CNC printers, and we saw some different mechanisms. So that inspired me to do something like this.
And you made a 3D printed part for this.
Yes.
Congratulations.
Yeah, thank you.
Congratulations.
Yes. So this is 6 to 7 rubber coated bearing, like the coat. Yes, ball bearing.
This one.
But yes, the coating is rubber.
Also the major over there. So the pen locking mechanism, as you can see, it is variable. If we fit a bigger diameter pen, it also fits over there. So it was variable.
So also speaking about this holder, like before this we 3D printed a different mechanism. Like in that we used just one screw, and it actually means this part was not different. Like it had just one hole and one screw. So basically, just when we tightened the screw, the brush was being stable. But that tried piercing the brush, and the brush was getting destroyed. So we tried this different mechanism, like 2 different screws at different sides.
You make 3D models yourself?
Yes.
Using what?
Fusion 360.
Fusion 360.
Yes.
Okay, interesting.
So what was the most difficult part of building the device?
For building, like taking the measurements exactly, like for all this, like before this I 3D printed one part, but it didn't swap rightly here, and also the like all these measurements, like where the length of servo horn, etc., all that mattered.
Also there is one point that this pen mechanism is variable. It can fit in any point of the chassis. It is removable. So according to the pen configuration required, we were ready to change the pen locations. It is removable and it can be fixed in any part of the chassis.
Just by so like it just swaps here in the chassis. Like this is 5 mm acrylic. So different function modes needed different phase shifts. So we need not do that in code. Like we can directly change the position of this mechanism.
So a few of the other teams did some sorting of the boundaries that they want to draw. Did you do anything like that?
Sorting of boundaries means
choosing which are the boundaries that you want to draw? Or
Yes. The selection of contours was done manually, as we have to trade off between the time and the image drawn. So we manually chosen the contours. We got the contours and we gave it a list of contours according to the strategy. Means if we want to get more time, we will give less contours or something like that. We were trading off between that. So we have not given it automatic because it can detect any contours and it might be not dependable for. It cannot be a strategical way for.
so if you did this again, what would you change?
If did this again, we would.
Design part, like the chassis part.
Yes, we can 3D print it, but it was not economical, so we have not done it. And the code can be done more modular, and more applications of ROS can be included better way. And yes, it can be made more robust from the code part itself.
Okay, thank you. Any other questions?
No, I have just one suggestion. Okay, I appreciated using bearings and all that. Okay, but you have used two bearings for every pane. No?
Yes.
Actually, the same thing you can redesign. Okay, and use only one bearing. Just think about how it can be. Of course, you are not engineer, you are not designer. Your backgrounds are quite different, and I appreciate that you have done wonderful mechanism which will take care of the smoothness and okay. But can I reduce the part? Can I? Okay, there is a possibility. Okay, even you use the ball bearing. Maybe there is a possibility of using roller bearing or nylon bearing. No? Nylon is wonderful material, and here the friction or the power which you are transmitting to the rotating shaft is hardly any. Okay, so even the nylon bearings are possible, and they are available in the market. Okay, that will just help you to reduce the most complex thing is the placing the motors. Okay, so maybe you should have thought of getting accuracy by 3D printing. 3D printing, those first group, okay, what they did, expensive way of designing 3D printed part. Actually, you could have reduced the 3D printing to the minimal. No? Chassis only can be 3D printed to get the accuracy of 120 degrees. No?
Yes. 120 degrees.
Good job. I like the approach.
Yes. Thank you.
Any comment?
Just the two of you did it. I'm quite happy to see this effort and it has come out well. I am a electronics engineer. I have also done stepper motors. I have
Yes,
spent
sir.
a lot of time on all of these. The thing that I would have really liked you to do better, and which another team has spent some effort on that, is reducing the board count.
Yes.
Right? Now you have cables running all over the place.
Yes.
You could have planned this board density better by, I'm not sure whether you had constraints that you must use certain boards or you had some flexibility of choices. But generally speaking, fewer boards, fewer cables running around, better it is. So if you could package them together better at least, so that these boards are piggyback one on top of the other mechanically, reducing the cable running around, right? That can make it better, right?
So actually in the previous task we used just the EFI mega board, so it did all the jobs. But I think at the submission of task 5, the Atmega section of our board got corrupted. So we were unable to use that section. So we had to use external Arduino Uno. So before this, all these things were done on just the one single board, EFI mega board. It was just like submission time, and these were the final tasks. So there was not enough time to parcel it and get new one.
Some people think that, oh, I have made everything modular and easily dismantleable and all of that. No, I should have fewest number of parts fewest number of parts, right? They should all be integrated. The cost today, once you ship this somewhere else, let's say you make this as a home vacuum cleaning bot, right?
Yes.
This is a perfect
Yes.
outcome of this, right? You can make a vacuum bot. The cost of going and changing just one part of the bot is not the cost of the part, is the cost of the person going, diagnosing and all that. It's easier to change the whole thing and get it back and fix it in the factory if you want it, right?
Yes.
So fewer parts, there are lesser chances of things losing connection and going wrong and so on. So keep that in mind.
Yes. Thank you.
You guys don't realize, but we are having a great time here, okay? Because the child comes out in us when we see good engineering and we see the engineering.